Imagine standing in your backyard under a darkening sky, watching the moon slowly dip into Earth's shadow, entirely unaware that a massive cloud of superheated solar plasma is currently hurtling through interplanetary space straight toward us at hundreds of kilometers per second. That isn't sci-fi, that is literally what is happening in our sky right now. A punchy M6.9 solar flare has unleashed a coronal mass ejection, and while the space weather gauges look eerily quiet this morning, the cosmic calm is about to break. You're listening to the Daily Space Podcast by Flarient, your daily conversation about space weather, solar activity, and cosmic events. I'm Ollie, and today is Friday, August 28th. Let's get into what the sun is doing today. Now, if you take a quick look at the live telemetry on Flarient.com right this second, you might be tempted to think absolutely nothing is happening up there. And I wouldn't blame you at all. The global KP index is currently sitting at a stone-cold 0. Over the past 24 hours, the maximum KP reached was a modest 1.33, with the GFZ Potsdam HP30 index lingering around 0.67. What does a KP of 0 actually mean for us on the ground? Well, in plain English, it means the Earth's magnetic shield is practically motionless at the moment. The geomagnetic field is extremely quiet, showing almost no disturbance. Aurora chasers in high latitudes would currently see very little activity, if any at all. Why is it so quiet? Look at the solar wind velocity. It is idling at a remarkably sluggish 273.8 kilometers per second. To put that into context, normal baseline solar wind usually cruises along at around 400 kilometers per second, and during high-speed stream events or CME impacts, it can easily exceed 700 or 800 kilometers per second. On top of that, particle density is hovering at an exceptionally low 0.3 particles per cubic centimeter. Essentially, Earth is currently sitting in a vast, low-density vacuum pocket of space. The DST index, which measures the strength of the equatorial ring current, is holding around -10 to -21 nanotesla. This slight negative value shows the subtle initial magnetic field deflection, but nothing alarmed just yet. So, is this quiet period going to last? Absolutely not. What we are seeing right now is classic silence before the arrival of a major space weather front. When that coronal mass ejection hits the magnetosphere over the next 24 to 48 hours, those low telemetry numbers are going to spike dramatically. We are keeping a sharp eye on the interplanetary magnetic field's BZ vector. Currently stable around positive 2.5 nanotesla, if that flips sharply southward, the energy transfer into our magnetosphere will trigger immediate geomagnetic storming. Now, let's pivot to some fantastic new blog articles published on Flarient today that explain the mechanics behind these cosmic phenomena. First up, we have an article titled How the Solar Cycle Dictates Global Ham Radio Propagation. If you've ever wondered how radio amateurs communicate across oceans without satellites, the sun is their main engine. The piece explains how high-frequency radio waves rely on the ionosphere, specifically the densely ionized F2 layer, as a giant cosmic mirror. During periods of high solar activity in solar cycle 25, intense extreme ultraviolet radiation ionizes the upper atmosphere, allowing higher frequency bands like 28 MHz or 50 MHz to bend around the Earth's curvature. When the sun goes quiet, that ionization drops, and radio signals simply pass straight through the ionosphere into deep space. It's a brilliant reminder of how our everyday ground tech is intimately tethered to solar rhythms. Speaking of atmospheric physics, our second article, Decoding the Colors of the Aurora, takes us directly into the chemical reactions taking place above our heads. When energetic solar wind particles cascade down Earth's magnetic field lines, they slam into atmospheric gases, transferring energy to local atoms. The classic, shimmering green light that most people see occurs when incoming particles strike atomic oxygen around 100 to 150 kilometers up. However, if oxygen is excited at much higher altitudes, above 200 kilometers where the atmosphere is much thinner, it emits a rare, deep crimson red. Nitrogen, on the other hand, gives off distinct magenta, pink, and purple fringes along the bottom edges of auroral curtains. So when you look at an aurora photo, you're literally looking at an elemental spectrum of our upper atmosphere. Our third article touches on a question I get asked all the time: the reality of predicting solar flares. Can we actually predict when a solar flare will burst? The short answer is, we can forecast probability, but we cannot predict the exact second an eruption occurs. Because electromagnetic radiation from a solar flare travels at the speed of light, it reaches Earth in just 8 minutes. There is zero early warning for the light itself once it snaps. What scientists do instead is track complex magnetic sunspot regions using space observatories like NASA's Solar Dynamics Observatory. By measuring magnetic shear and flux, forecasters assess whether an active region has a 10% or 80% chance of launching an M or X-class flare. We also have a How Solar Wind Shapes Earth Magnetosphere, detailing how the constant stream of plasma carves out our magnetotail and creates a supersonic bow shock in front of the planet. And rounding out the blog updates, the life cycle of stars, from nebulae to stellar remnants, gives us the grand cosmic picture. It traces how gravitational collapse in interstellar gas clouds ignites nuclear fusion, forming stars that balance gravity against radiation pressure for billions of years before casting off their outer layers to seed the cosmos with heavy elements. Moving on to space events, the major spotlight today is squarely on the solar storm trajectory combined with an astronomical treat. Back on August 25, active solar regions produced a powerful M6.9 solar flare. While M-class flares are considered medium-scale compared to giant X flares, this event launched a robust coronal mass ejection directly into the Earth-Sun line. NOAA's Space Weather Prediction Center has officially issued a geomagnetic storm watch that extends through August 29. We are anticipating potential G1 to G2 minor to moderate geomagnetic storm conditions as the leading shock front of this plasma cloud arrives. Why does a G2 storm matter? Well, moderate storms can cause high-latitude power grid fluctuations, voltage alarms, and subtle satellite orientation adjustments due to increased atmospheric drag. For Aurora watchers, a G2 storm lowers the auroral oval, making the northern lights potentially visible across Scandinavia, the UK, northern US states, and southern Canada. Adding to this cosmic theater, Earth is concurrently experiencing a partial lunar eclipse visible across Europe, Africa, Asia, Australia, and parts of the Americas. As the moon glides through Earth's umbral shadow, sky watchers are treated to a rare double-header, observing orbital mechanics in real time while waiting for geomagnetic particles to light up the thermosphere. Meanwhile, in deep space tracking news, near-Earth asteroid 2022 UP6 is making a routine close approach. Posing zero-impact hazard to Earth, its trajectory is being monitored by radar tracking networks as part of ongoing planetary defense survey missions. Now, let's take a look at two intriguing claims in our fact-check section today. The first claim floating around online forums states, the universe as observed is an engineered quantum computer. What's the verdict on this one? It is classified as unverifiable. Here's why. Prominent theoretical physicists like Seth Lloyd have mathematically modeled physical laws using quantum information theory, showing that quantum state transitions can be described computationally. However, claiming that the universe is an engineered quantum computer implies intentional design by an external entity, which moves the idea entirely outside the realm of empirical science. Furthermore, recent computational complexity analyses demonstrate that simulating every quantum state of the observable universe would require physical resources exceeding the universe itself. Because the claim produces no testable, falsifiable predictions, it remains purely philosophical speculation rather than scientific fact. Our second fact-check addresses a surprisingly common internet query: does planet Mars have gravity? Verdict: true. Every object containing mass exerts a gravitational pull. Mars has a mass of roughly 6.39 times 10 to the 23rd kilograms. Surface gravity on Mars measures approximately 3.71 meters per second squared, which translates to about 38% of Earth's gravity. If you weigh 100 kilograms on Earth, you would weigh roughly 38 kilograms standing on Mars. Decades of orbital insertion burns and rover landings by NASA and ESA confirm this precise value down to the decimal point. Bringing everything together in today's daily brief, we are witnessing a brilliant intersection of space weather and sky watching. We are currently sitting right on the precipice of a CME impact following the M6.9 flare from August 25. As the plasma cloud makes contact over the coming hours, watch for solar wind speeds to jump from 270 km per second up toward 500 km per second, accompanied by sharp increases in proton density. Satellite operators are taking precautions for atmospheric drag, utility providers are keeping an eye on grid telemetry, and high-frequency radio operators should anticipate brief signal degradation on HF bands. If you're heading out to view the partial lunar eclipse tonight, bring a camera and keep an eye on the northern horizon just in case geomagnetic activity kicks off early. That wraps up today's main broadcast. Before you head out to check the night sky, make sure to check out these essential Flarient community resources. Visit flarient.com for live space weather data, real-time KP index, Aurora forecasts, and interactive dashboards. It is the official website of Flarient and the best place to see what is happening right now. Subscribe to the podcast on your favorite platform so you never miss an episode. Visit flarient.com/podcast for all episodes and show notes. Follow Flarient on social media for real-time space weather alerts. Join the Flarient community for Aurora chasers and space weather enthusiasts. Download the Flarient app for push notifications when geomagnetic storms hit. Thank you so much for tuning in today. Keep your eyes on the skies, stay curious, and I'll catch you again tomorrow on the Daily Space Podcast.